In this video, we're going to take a look at areas of regions that are not your standard kind of region, so not things that are just rectangles or triangular shapes, but we'll look at some regions under curves that are, more rounded. So an area under a curve like this. What's this area? Right here. But before we do that, we need to look at some notation related to summations. So let's jump into some of that. So here we have the sigma notation. So the sum of the terms a1, a2, a3, up through an, it is written as a sum from I equals 1 to n of a sub I. Right, so this tells us that that subscript is going to start at 1 and it's going to end at n, and we will go through all of those values, right? So this is where it ends. So I ends here. And this is where our I will start. Perfect. This Greek letter sigma, right? So that funny looking E thing, that tells us to sum these things. And the a sub I, these are the terms to add together. So here we're starting with I equals 1, so we're plugging 1 in for I, and so we have a1. Plus, then we bump that value of I up 1, plus a2. Then we bump the value of I up again, plus a3. And we keep doing that all the way up to a sub n, and that's where we stop. I is the index of summation. So that's what the letter I, or that's the terminology we will use. A sub I, that is the ith term, and the values n and 1, those are the upper and lower bounds respectively. All right, so let's go through a couple examples, and we will find some sums. Here we want the sum from I equals 1 to 4 of 3i plus 1. So I'm going to write this out. We would have 3, we'll plug in 1 for that value of I, plus we'll then bump it up 3 times 2, plus 1, plus 3 times 3, plus 1, plus 3 times 4, plus 1. So we're adding all of those terms together. This is our I equals 1 term. This is our I equals 2 term, the I equals 3 term, and the I equals 4 term. So we have 4 plus 7 plus 10 plus 13, and if we add it together, that sum is 34. Excellent. Let's look at the next example. Here we have a sum k equals 1 to 6 of k squared. So our index is k. We're starting at 1, so we have 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared. And that's where we're going to stop. Why do we stop there? Because that's our upper limit of summation. So we plugged in k equals 1 up through k equals 6. So this is 1 plus 4 plus 9 plus 16 plus 25 plus 36. And when we add all of that up, we get 91. So that is the sigma notation. That will be important for us to know as we look at trying to find some of these sums that are a little bit less standard. So some of these areas that are a little bit less standard. All right, so in our next video, we're going to look at a lot of summation formulas that will help us to evaluate some of these when we are going up to larger values, right? So here we stopped at 4 and 6, and so it was easy enough to write those out. But what if we went up to 100 or 1,000? Or if we went up to some arbitrary value n, can we come up with sums to represent that? Can we add those together using a formula? So we'll look at that next time. We'll see you there.